So in this episode, in this podcast, I want to talk about the string class. I'd like to do this primarily because the string class is used so often in programs. And as we get into doing different examples and whatnot, we're going to be using this quite extensively, and there are a number of things in this class that we can use for writing even simple programs. So Java has a special class called string, and The these are objects, so they are not primitives, which means we do have to instantiate them using a constructor. And this can happen in two different ways. The first is to use just a string literal and assign that to a string variable, or we can use the new operator. As far as Java is concerned, and as far as the compiler is concerned, these are identical constructions. Now, a string is simply just a sequence of characters, um, and typically we create string literals with double quotes. If you're thinking about locations within a string, so location 2, for instance, in a string is 0 delimited, or sorry, it starts from 0. So, um, for instance, in the word hello with three exclamation points, the second location would be an L. Now, string literal constants are um, denoted using double quotes. And so here are a couple of examples. Hello, and today is Wednesday. You can also have an empty string, which has no characters. Um, Now, when using using the constructors, you can again use these two different forms. There's a third version here of string equals null, s1 equals null, and that basically just sets the variable to point to basically no object, and null would be essentially you'd be pointing to nothing in that case. So it initializes the variable, but it doesn't actually have that refer to any specific object. Now, as I mentioned before in one of the previous podcasts, variables of non-primitive types store a reference or address to where the object is actually stored. That is no different for using strings. And again, you have to remember, how aliases work and how if you have an assignment of two strings, you do need, and you do them as direct assignments, then you will be creating an alias rather than doing a copy. So here's an example of how this would work. So if I have two strings, a string and a number, a value gets stored in the number, and the string is a reference. Uh, and if I do these assignments, what you get is a value, and then you get a reference. In this case, it's being represented here as a pointer to the memory address that is carrying the string object. So as with every other variable in a complex data type, the strings only copy references. I mentioned this before. So if I have uh, these two examples, the values get copied for built-in types. The references get moved for the for object types. This is similar to an example that I had shown earlier. Now, as far as displaying strings goes, we've been doing this already. We use the system.out.print or print line to print objects. Again, this is nothing new to us. We've seen this in many examples. Um, we can also concatenate strings, um, and we use the plus operator to do that. So if I have two strings s1 and s2, and I do this concatenation into S3, what we get is a new string called hello world. And then note that S1 and S2 are unchanged, and that this instantiates, constructs a new object, S3, that uses the values from the other two strings plus the space indicated by this double quotes with the space. We can also concatenate other types, and remember that these what happens is that these values get turned into strings, so they do get promoted into strings. So pi, for instance, here would get changed into a string. So strings can contain escape sequences. So escape sequences typically start with a backslash. So I don't know if they're in this set of slides, maybe in another set of slides, a list of all the different escape sequences that are available. Otherwise, I can certainly look that up and provide it as reference. But as with many languages, these escape sequences define special characters like new lines and tabs and backspaces and a number of other things, single quotations and whatnot. So, so for instance, this backslash single quote gives me a single quotation within a double quote. So, so here are some of the common escape sequences that are available. So new line going to start at the beginning line of tab, double quote, single quote, and so forth. So remember that concatenation does promote the value into a string, and so we're not actually doing arithmetic here. We would get 1 1 space test with the first one. Same with the second thing, we would get test followed by 1 1, whereas we would get an actual addition here. Actually, the first one, it's left to right, so this would actually get evaluated, and then we'd have test. Anyway, we'll see this in an example that we'll do in Eclipse in an upcoming episode. Now, in the one of the previous episodes, we also looked at the scanner class, and the scanner class can be used to read strings. I think in the example that I did, we were looking at reading in an integer, but you can also use that to read in strings. So by doing just like a keyboard next line instead of a next int or whatever, this next line will actually read the entire line as a string. Now there's a number of methods available that are part of the string class, and a lot of those methods, actually all those methods, are described in the Java doc for the string class. A lot of the methods are non-static, which means that you have to instantiate the object in order to call the method. So one such method is the length operation. So if I have a string s1 instantiated as hello, and s1.length would give me the length of the string. You can do a number of things, like I can take this string here, world, and do a length on it, and it will treat this string literal as a string. You can also inspect characters within a string using this index. So character at will give you the string that is at a specific index. Remember that the indexes start with 0 rather than 1. We can also create substrings from a string, essentially starting with a starting index and an ending index give me the substring. So for instance, here's an example. A substring of s1 from 0 to 5 would give me hello. From 3 to 6 would give me low. You can also search for strings within a string. If you pass a string to the index of method of a string, it'll find the first occurrence of that string within the larger string. So for instance, if I have a string initialized to say hello to hello, and then pass hello to the index of method, it will give me the index of this first thing. So it's 0, 1, 2, 3, 4, index 4. You can also do a last index of, which will give you the last occurrence of a substring within a string. So you see that here. Last index of hello to this string again would give me 13. So position 13 in this larger string. If it's not found, as with the previous version, if it's not found, then the method returns the value -1. So here's an example. We'll actually run through this example in a following podcast, but I wanted to put it in the slide so that you had something to refer to. We can also do case conversion. So convert all of the letters to either lowercase or uppercase. So this is the case of the method for doing lowercase. It turns everything in the string to lowercase. If you want to convert your string, you need to remember that that you should do an assignment or assign it to a different string. Otherwise, you lose the return value. So the to lowercase does return a string, and if you don't assign it to something, it will essentially go nowhere. To uppercase works the same way. It converts everything to uppercase. We can also trim strings. So trimming a string will essentially take all the trailing white space out of the string. So both spaces and new lines and tabs and so forth. And again, another example. Again, we will go through a similar example in a following podcast. Let's see. Another helpful method is replacing characters. So taking characters out of the string and replacing them with new characters. So for instance, we can replace all the i's in this string with an asterisk, and this is all lowercase i's. So we end up with the string shown here in the comment. Now another, probably one of the more important methods is the equals method. This tells us whether or not two strings are equivalent. Now if you try to set two strings, say S1 and S2, with the double equals operator to check equivalence, it will check to see whether or not the two objects are referring to the same object. And so what we actually would want to do is check to see whether or not two strings are logically equivalent, and so we use the equals method for that. Equals ignore case is similar. It just ignores the case for the string, but it works in the same way. And I notice here there's a typo. It should be equals ignore case. Now we can also do you can do lexicographic comparison using compare to, and the values that are returned will tell you whether or not two strings fall sort of lexicographically in order. So if they're equivalent, then you get 0. If S1, as it would be read in a dictionary, for instance, is less than S2, then you get a value that's less than 0, and likewise, or conversely, if S1 is greater than S2, then you get a value that's greater than 0. The value that it returns, you should check against greater than or less than, rather than equivalence to 1 or -1, because I think it's undefined as to whether or not it will actually turn 1 or just some number that's greater than 0 or less than 0, whatever the case is. And let's see, so another similar thing is compare to ignore case, same idea. Is just doing this lexicographic ordering but ignoring case. So anyway, so that ends the, that's our quick overview of the string class. There are many more methods that are available, and I would have you take a look at the string Java doc for more information.